Hello everyone, welcome to this presentation on arrays and strings in C programming. Myself, Ramya, student of CMR University. I am currently pursuing my BTech course in CSE Data Science. This presentation is part of the course Programming in C offered at CMR University. My faculty guide for this course is Dr. Nagaraj Choli sir. Now, let's dive into the topic and explore how arrays and strings work in the C programming language. Let's begin by understanding the basics of arrays in C. Firstly, what is an array? An array in C is a data structure that stores a fixed size, sequential collection of elements of the same data type. It provides a way to organize and access multiple values using a single identifier. Each element in an array is located at a specific index starting from 0. Nextly, what is the use of an array? Arrays are used to store a collection of elements of the same data type in contiguous memory locations. This makes it easier to manage and manipulate multiple values using just one variable name and an index. Now, let's look at some key features of an array in C programming. Firstly, homogeneous data type. An array stores elements of the same data type. This means an array of integers can hold only integers and an array of characters can hold only characters. Second, fixed size. The size of an array is fixed at the time of declaration. It cannot be changed during the program's execution, and the 3D size must be known at a compile time. Thirdly, random access. Arrays allow random access to their elements. This means we can access any element directly using its index, and this operation takes constant time. Then, array size. The total size of an array is the memory it occupies. This is calculated as the. Let's continue exploring some additional characteristics of arrays in C. Arrays as return values indirectly. While functions in C cannot directly return arrays, they can return pointers to arrays or structures that contain arrays. This is a useful workaround to share array data between functions. Then, memory efficiency. Arrays are memory efficient because their elements are stored in contiguous memory locations, resulting in minimal overhead. Then, traversing arrays. We can easily traverse arrays using loops. This allows us to process each element one by one in a sequential manner. Array initialization. Arrays can be initialized at the time of declaration or later using loops or other logic based on. Now, let's understand how arrays are declared and initialized in C. Declaration of an array. An array declaration defines what type of elements the array will store and how many elements it can hold. The general syntax for declaring a one-dimensional array is data type into array name of array size. Data type refers to the type of elements the array will store, such as int, float, character, and so on. Array name. It is a valid identifier that represents the name of the array. Array size. It is a constant integer expression that determines the number of elements the array can hold. For example, if you want to declare an integer array named numbers that can store 5 integer, you would write int numbers of. Let's talk about declaring and initializing an array without specifying its size. In C, if you declare an array without providing its size but you immediately initialize it with a list of values, the compiler will automatically set the array size based on the number of elements in that list. For example, now Let's look at how to initialize an array in C. Initialization means assigning values to the array elements. This can be done either at the time of declaration or later in the program. You can provide a list of values enclosed in curly braces. For example, int numbers of 5 is within the curly braces of 10, 20, 30, 40, 50. This creates an array of size 5 and assigns each other element a value from the list. If you provide fewer values than the array size, the remaining elements are automatically initialized to 0. In C programming, after declaring an array, you can initialize its elements individually by using their index. For instance, if you declare an integer array named numbers with a size of 5 like int numbers of 5, you can then assign values to each element using its index. So numbers can be set to 10, numbers can be set to 20 and so on up to numbers being set to 50. Now, let us see more on initialization of arrays in C programming. If a list of initializers is shorter than the number of array elements, then the remaining elements are initialized to 0. If an external or static array is not initialized, then the system automatically initializes all elements to 0. Uninitialized automatic and constant arrays start with garbage values, which are whatever happens to be in memory when the array is allocated. Now, let us see about types of arrays, mainly one-dimensional array, which is also known as 1D array. A one-dimensional array is a data structure that stores a list of elements of the same data type in a contiguous block of memory. It can be visualized as a single row or column of values. Each element in the array is assessed using an index starting from 0 that corresponds to its position in the list. Example is as given below. Now let's see about the key characteristics of 1D array. It includes data type consistency. All elements must be of the same data type, such as all integers, all strings, or all floating point numbers. Next, contiguous memory. Elements are stored in consecutive memory locations, which makes it easy. Now, let's see a small example on 1D array C program. This image shows an example C program designed to store three numbers in a 1D array and calculate their sum. The program initializes an integer array named numbers with a size of 3 and an integer variable sum to 0. It then prompts the user to enter three numbers, reads them using a for loop and the scanf function, and stores them in a numbers array. Inside the loop, it also adds each number to the sum. Finally, it prints the calculated sum using printf and returns to 0 to indicate a successful execution. The example input provided is 10, 20 and 30 and the corresponding output sum is equal to 60. Therefore, this is a small C program based on addition. Nextly, we'll see about two-dimensional array, which is also known as 2D array. They're also known as matrices or data structures that organize elements in rows and columns. They are useful for representing tables, grids, and mathematical matrices. A 2D dimensional array can be thought of as an array of arrays where each element in the outer array is itself an array. The key characteristics of 2D array include rows and columns. Data is arranged horizontally in rows and vertically in columns. Then indexing. Indexing in elements are accessed using two indices, one of the row and one for the column. The index starts at 0 and ends at the length 1. Next, matrix representation. They are often used based on 2D array. This image shows a C program designed to store elements in a 2 into 2 matrix and then print the matrix. The program begins by including the standard input or output library and declaring a 2 into 2 integer array called matrix. It prompts the user to enter 4 elements for the matrix, reads these elements using nested loops and the scan function, and stores them in the matrix array. Finally, it prints the matrix to the console. Again, using nested loops and the printf function, the output would be displayed as 2 into 2 matrix with elements arranged in rows and columns. Here, if we give the input as enter the elements 1, 2, 3, 4, then we click the enter button. The output would come in 1, 2, 3, 4 in the form of 2 into 2 matrix. Next, three-dimensional array. 3D array is a data structure that organizes data into layers, rows, and columns, similar to a cuboid or cube. It can be visualized as a collection of two-dimensional arrays where each 2D array represents a slice within 3D structure. These slices are stacked together to form a complete 3D array. Dimensions. A 3D array has three dimensions typically represented as array of I into j into k. I represents the layer or slice number. J represents the row within a slice. K represents a column number within a slice. Accessing elements. To access a specific element in a 3D array uses 8 indices. For example, array of 0, 1 and 2 would refer to element in the first layer index 0, second row index 1 and third column index 2. The total number of elements that can be stored in a multi-dimensional array is calculated by multiplying the size of each dimension. For instance, an array of size 10 into 20 and 30 can store 10 into 20 into 30 is equal to 6000 elements. Now let's discuss about various applications involved in 3D array. It includes image processing. They are used for representing 3D images like medical scans or 3D models. Next, data analysis. They facilitate the storage and manipulation of 3D data in various fields. Next, game development. They are used to represent the 3D environments and objects. Next, scientific computing. They are utilized for modeling and stimulating the. Let's discuss a small program. This image shows a C program designed to add two 3D arrays and display a resulting array. The program initializes a 3D array with the values as given there. It then prints the elements of this array using nested for loops. However, the program is incomplete as it only initializes one array and doesn't include the logic for adding two arrays or storing the small result in the third array. So the code has a syntax error. The inner curly braces for the array initialization are not properly closed. To correct and complete the program, a second 3D array needs to be initialized. The addition of logic needs to be implemented and the result should be stored in a third array, which is then displayed. Now let's discuss about memory layout of arrays in C programming. In C, arrays are stored in contiguous blocks of memories. This means that the elements of an array are placed one after the another in memory without any gaps between them. The memory layout of an array depends on its dimensions. For a one-dimensional array, the elements are stored in a single continuous block of memory. The address of each element can be calculated by adding an offset to the base address of the array. The offset is determined by the size of the element type and the index of the element. For example, if array is an integer, the address of an array calculated as given below. Now let's discuss about few limitations of arrays in C. Mainly insufficient insertion or deletion. Inserting or deleting elements in the middle of an array requires shifting subsequent elements, which can be time consuming, especially for large arrays. Next, Lack of built-in methods. Arrays in C do not have built-in methods for common operations like searching, sorting, and resizing. These operations need to be implemented manually. Not first class object. Arrays in C are treated as first class objects, meaning they cannot be directly copied or pasted as arguments to function. Instead, they decay to pointers. Next, no direct support for jagged arrays. In C, C does not directly support jagged arrays, nothing but arrays of arrays with different sizes. While they can be implemented using pointers, it adds complexity. These limitations highlight some of the challenges and considerations when working with arrays in C, particularly in scenarios requiring frequent modifications or complex data structures. Common errors in arrays in C program include assessing out of bounds, trying to access an index outside the array size. For example, trying to access array size 10 when the array size is 5. Uninitialized arrays, using array elements before assigning values, which can lead to garbage or unexpected results. Off by one errors, confusing index limit such as using I lesser than or equal to n in a loop instead of I lesser than n. Wrong loop nesting, incorrectly swapping or using loop variable in nested loops. Example in 2D and 3D array. Forgetting to allocate enough space, using arrays without declaring the correct size, which can cause the runtime errors or incorrect results. Let's see about a real world application of arrays in C programming. Firstly, game development. Two-dimensional arrays are used for game board in games like tic-tac-toe and chess, while 3D arrays are employed for 3D maps or levels. Image processing. Images are stored as 2D arrays for grayscale images and 3D arrays for RGB images, with each element representing a pixel's color value. Scientific computations. Arrays are essential for storing large datasets used in simulations and physics models. Data Data tables and matrices, spreadsheets, mark sheets, and data grids utilize 2D arrays to organize and manage data. Audio and video buffers. Audio are used to store and stream audio or live video data in a sequential manner, enabling playback and processing. Let's discuss about the relationship between arrays and pointers in C programming. Arrays, names and address. An array name represents the memory address of the array starting element. Memory allocation. When an array is declared, the compiler allocates a base address and sufficient memory RAM to store all the array elements. Base address. The base address of an array is the initial memory location where the array is stored. First element address. This base address also corresponds to the address of the first element in array, which has an index of 0. In C, pointers can be manipulated using arithmetic operations, which is useful for navigating arrays. When a pointer is incremented or decremented, it moves to the next or previous memory location of the same data type. Adding an integer to a pointer shifts it toward in memory by a number of bytes equal to the integer times the size of the data type it points to. Similarly, subtracting an integer moves the pointer backward. Pointer can also be compared using the relational operators. This slide discusses the equivalence of int a and int.a in C. It explains that while int a and int.a are equivalent when used as part of the header of a function definition, they differ in behavior within a body of a function. Specifically, int a in a function header is equivalent to int.a, both indicating a pointer to an integer. However, inside a function body, int a creates a constant pointer without allocating the storage for an array, whereas int.a creates a pointer variable. Now let us discuss about passing arrays to function in C programming. Firstly, arrays as pointers. In C, when an array is passed to a function, it is treated as a pointer to a first element of the array. This means that the function receives the memory address of the beginning of the array, not a copy of entire array itself. Next, call by value of base address. When a array is passed to a function, its base address is passed by value. However, since this value is an address, the function can still modify the original array elements. Array elements not copied. The array elements themselves are not copied when the array is passed to a function. This is efficient especially for large arrays as it avoids overhead of copying a large bracket notation for pointers. C allows the use of array bracket notation when declaring pointers as parameters. This provides a convenient way to work with arrays within functions, even though they are technically being handled as pointers. Lastly, receiving the address. The function receives the address of the array's first element, enabling it to access and manipulate the array's content. Here, there is a small example. This C code calculates the sum of elements in an integer array. Here's a breakdown. This line includes the standard input or output library, which provides function like printf for printing the console. This definition makes a function named sum that an integer array a and its size n as input. It initializes a variable to s to 0. It uses a for loop to iterate through the array, adding each element to s. Finally, it returns the calculated sum. Int main. This is the main function where the program execution begins. It declares an integer array and initializes it with values. It calculates the size of array by dividing the total size of the array by the size of its element and stores it in size. It calls the sum function with array and size as arguments and stores the result in the result variable. It prints the sum of array elements using printf. It returns 0, indicating the successful program execution. The output, the program prints sum of array elements 50 to the output. Now, let us discuss about strings in C. A string in C is defined as a sequence of characters that ends with a null character denoted as 0. Unlike languages like Python or Java, C doesn't have a built-in string type. Instead, strings are represented using character arrays. In C programming, a string is treated. Let us discuss about declaring and reading strings. Firstly, declaring strings. In C, strings can be declared and initialized in several ways. Firstly, using a character array with a specified size. Character of string 6 is equal to hello. This declares a character array named string with a size of 6, which can hold the string hello and the null terminator. Secondly, using a character array without a specified size. This declares a character array named string and automatically allocates enough space to hold the string hello and the null terminator. Manual initialization. Character string. This initializes the string character array by explicitly assigning each other, including the null terminator. Reading strings. There are different ways to read strings in C. Firstly, using scanf. This reads a string from the input and stores it in the string array. Note, scanf stops reading when it encounters white space, example, space, tab or new line. Secondly, using gets deprecated. Gets. This reads a string from the input and stores it in the string array. Get. This explanation covers the basic concepts of declaring and reading strings in C programming as presented in this slide. It is important to use safe and recommended methods like F gets for reading strings to avoid the potential security issues. Well, thank you for your valuable time and please like and subscribe my channel.